Bismillahirrahmanirrahim. In this video, we'll be discussing example 3.1 from LTI system, complex exponential, chapter number 3. And this may be a repeat. I had made longer videos, but this is a short video to give you some idea about two items, that is the eigenfunction and eigenvalue. Now, the name is difficult and does not convey any meaning really. What is eigen? It's a German word, and it means its own or inherent to something. But for memorizing or to understand its meaning, I have replaced function by signal. So when we say eigen signal, that means this is some kind of a input signal. So let's see the definition. If this is an LTI system and we have input EST and we get an output of this form HSEST. So this input which produces this type of an output is called eigenfunction. So eigenfunction can be defined as a signal for which the system output is a constant, this constant times, so multiplied by the input EST. So this is the input. So this type of signal which produces or which reproduces itself at the output with some other constant is called the eigenfunction. Now this is for continuous time signal. Discrete time signal, we use Z and N, and this will be the output for discrete time signal. So according to the definition, EST and Zn are the eigenfunctions of the system. And the eigenvalue is the constants. So these two constants, Hs or Hz, they are called the eigenvalue. Okay, with this in mind, now let's solve example 3.1. Consider an LTI system for which the input is xt and output yt are related by a time shift of 3. That means yt is x shifted by 3, t minus 3. So if this is a linear system and the input is xt, then output will be x t minus 3 shifted by 3. Now the question is, if the input to the system is a complex exponential signal, this signal, then find the eigenfunction and eigenvalue. So let's see what this is the input. This is our function or our system which shifting time by 3 or t minus 3. And we have to find the eigenfunction and eigenvalue. So the first thing we'll do is just shift this t by t minus 3. So t is changed to t minus 3. And now we can separate this or write it in two parts, just like this. So EJT, first part, and the second part is E minus J6. Now minus J6 is J2 and minus 3, so minus J6. So these two are the terms that we are getting at the output. Now in the definition we had seen that it is preferably written as HSEST. In our case, this is EST or the input, so we'll write it in this manner. So EST or EJ2T we are writing at the end, and this is coming at early. So this, if you compare now, so this will be our eigenvalue and this will be our eigenfunction. So by inspection, the eigenfunction is EJ2T. So this is the eigenfunction, or from here you can say this is the eigenfunction. And the eigenvalue is, now instead of hs, we'll call it hj2. Why j2? Because this one, the signal, instead of est has ej2. That means s is j2. So this will be j2. And this value, e raised to the power minus j6, is the value or the eigenvalue. This is first part. The second part has a different type of a signal. Here also we have to find eigenvalue and eigenfunction, and will also pass through the same circuit that we had. Now to get the eigenvalues and eigenfunction, our signal must be in complex form. We'll use Euler formula to convert the cosine into complex form. And so using this formula, cosine 40 can be written as half e raised to the power j4t from here. Cos 4t will be e j4t plus this one half e raised to the power minus j4t. Similarly, the second one will be e raised to the power j7t. This is 7. And the other part of it will be half e raised to the power minus j7t. Now this signal will pass through the LTI system, which shifts t by 3. So when we pass this, all the t's will be shifted by 3. So t minus 3, t minus 3, t minus 3. And from here, if we break it, open the bracket, then we get these two terms. And as discussed in the previous slide, we should write the constant first and the variable later on. So this is our variable. So this goes at the end, and this should come first. So let's write it. So this will be coming first. This is the constant term, and our signal in all this. And so from here we can say that the eigenfunction, that is the variable or the input, this is for the first case, second case, third case, and fourth case. And the eigenvalue is the first one, this one, then this, and this. So this is how you find the eigenvalues and eigenfunctions and eigenvalues. I hope you have been able to follow this. Please let me know through your comments. Thank you.